Hi there. We are in chapter 20 of WAVE looking at carboxylic acids, and we're currently looking at reactions to either make or carboxylic acids or have them react to form other things. And in this lecture, we're going to look at the synthesis of carboxylic acids. And there's three ways I want to go over how we can make carboxylic acid. Two of these are kind of review, and one you probably haven't seen yet. All right, so method one method one is we're going to take alcohols and we're going to turn them into carboxylic acids. Okay, so I'll just take, and we're going to take primary alcohols to do this. So I've got butanol here, and it's a primary alcohol. Okay, and we're gonna oxidize it, but we're not going to stop at the aldehyde oxidation state. We're going to blow right on through to the carboxylic acid. And there's two methods that we've learned how to do that. There's lots of oxidants out there, but I've emphasized this semester is using sodium hypochlorite, which is bleach. Okay, and we're going to use excess of that with tempo. Okay, and that. Or instead of those, we could use potassium, some sort of dichromate salt. In this case, K2CR2O7 with sulfuric acid. Okay, the combination of these two makes chromic acid. Okay, both of these are strongly oxidizing conditions. Means they can oxidize us all the way to butanoic acid. Okay, note here that we aren't adding or taking away carbons. We're simply doing a functional group conversion. We're going from alcohol to an carboxylic acid. We're changing the oxidation state at that carbon. Okay, so that's the first method we can use to make carboxylic acids. All right, the second method allows us to start from an alkyl halide, and this is going to be via Grignard reagents. Okay, let's start with 4 carbons. Okay, this lecture today is brought to you by the number 4. Okay, so here I've got 1 bromobutane. All right, and through a series of 3 steps, we're going to start with magnesium and diethyl ether. So that makes the Grignard reagent, if you recall, that turns this into, we do an oxidative addition into this bond, and we make a magnesium bromide. Okay, and secondly, we're going to take that Grignard reagent and we're going to do a nucleophilic addition reaction into a carbonyl compound, and specifically carbon dioxide. Okay? And that's going to add a carbon to our chain. All right? And then thirdly, we're going to do a workup. And ultimately, what we're going to get, we're going to add a carbon here. Go from 1 bromobutane to pentanoic acid here. Okay, so this CO2, there's the oxygen, the carbon, and another oxygen. Okay, so that's the second method we can use to make carboxylic acids. In this case, we're getting the carboxylic acid from an alkyl halide, and we're adding a carbon in the process. Okay, so not only are we doing a functional group interconversion, but we're also adding a carbon to the chain. All right, and the third method is probably something we're not very familiar with yet, and that is we're going to go through nitrile. All right. I'm going to start, now we're still going to start with an alkyl halide here. I'm going to start with the same one, 1-bromobutane. Okay. And what is the first thing I'm going to do with this? I'm going to add sodium cyanide to it. Okay. And so the sodium is just a spectator ion. Okay, it's just watching things. This is a nucleophile, this nitrile. So this does an SN2 reaction here to displace the bromine. All right, we're going retro here. We're going back to the 80s or going back to our chapter on SN2 reactions from first semester. Okay. And what this does, okay, there's our nitrile. Br minus, or sodium still hanging out here. All right, and then what we can do, and what we probably haven't seen yet, is we could do either acid catalyzed or base catalyzed hydrolysis of this. Okay, this would be acid catalyzed hydrolysis. What we're going to do is we're going to ultimately lose that nitrogen, and we're going to replace it with a couple of oxygens. Okay. So acid catalyzed hydrolysis, and that gets us to pentanoic acid. So again, this basically accomplishes the same thing as our last method. We're converting from an alkyl halide to an acid, and we're using water. Okay, and we're adding a carbon. I don't like this method as much because you have to use sodium cyanide, and you have to be careful with any cyanide salt because under acidic conditions you make HCN, and that's hazardous. You don't want to breathe it because it can poison you. So if I were doing this myself, I'd probably try to use method 2 rather than method 3. All right, thanks for watching. Have a good day.